Good afternoon, class. I'm just going to wait a few seconds to make sure the live stream works. It appears to be holding, so we will continue. This is an introduction to acids and bases. Acids are substances that release hydrogen ions into water.
Mr. Marchese, Marco Marchese, please contact the main office. Thank you.
I'll start that over. Hi. Hi, Eden. I see you now. I see your little banner. Good to see somebody's watching. Yes, it's for grade 9. It could also be watched by grade 10s, but it's primarily for grade 9s. I kept it very introductory for grade 9s. So you should know this. Okay, so acids are substances that release H plus into water. Sometimes you'll see the H plus portrayed a different way. They just couple it to a water molecule. So if you take a H plus and you put it with a water molecule, you get what's called a hydronium ion. And that's probably a better way of portraying H plus, because H plus is just a naked proton. It's not going to be sitting, it's not really the way it happens. So they usually will say yeah, I'm back. Somebody interrupted it, my live stream with a phone call, but I'm back. We'll resume the explanation from the top. So I was saying that acids are substances that release H plus in water. They turn litmus paper red, they taste sour, and they make the pH of water become less than 7. So if anything has a pH less than 7, it's considered acidic. Another way of portraying the proton is to combine it with water, and you get what's called a hydronium ion. Let me write that for you, hydronium. So anything that also increases the concentration of hydronium is considered an acid. We have what's called a pH scale for measuring how acidic or basic a substance is. Typically, anything with a pH less than 7 is considered an acid, and the pH is a direct measure of the concentration of the hydrogen ions in solution. You don't have to know that much if you're in grade 9, but it's just good to peek ahead. So if the pH equals 1, it means you have a concentration of 10 to the minus 1 molar. So it's based on a logarithmic scale. pH is 3, then that means the concentration of the hydrogen ion is 10 to the minus 3, and so on. So the lower the number, the stronger the acid. So a pH of 1 is a pretty strong acid. If you get down to pH 0, yes, this is for grade 9. If you get a pH 0, it means the concentration of H plus ions is about 1 molar, which is what you would use, say, to etch concrete. They have something called muriatic acid, which might be even stronger than that. It'll have a pH of -1, which means it's a concentration of H plus of 10 moles per liter. You don't have to really know that. Don't worry about it. It just suffices to say that it's concentrated acid. If you spill it on concrete, you can hear it fizzing because it actually eats into the concrete. So that's hydrochloric acid that will do that. There are 7 strong acids that we know about. Well, there aren't others that are mineral acids. There are other strong acids, but these are the 7 strong mineral acids, and they are nitric acid, sulfuric, chloric, perchloric, hydrochloric, hydrobromic, and hydroiodic acid. The way to memorize them is to make a word out of it using only the anion part of the molecule, because you know the front is all hydrogens, right? So you're going to say no, so, claw, brie. No, so, claw, brie. And then you write 3, 4, 3, 4. And you put the hydrogens in front. Just keep in mind that sulfuric acid has 2 hydrogens. And that's the best way to memorize all the acids. Just make a little word out of the anion part. About bases. Bases are substances that release OH minus into aqueous solution. That's called hydroxide ions. They turn litmus paper blue. They have a bitter taste, but don't drink. They have a soapy feel. And concentrated bases are ideal for cleaning grease based on animal fats, because they turn animal fats into soap, which is why when you get some base on your hands, it feels soapy, because what it's doing is it actually reacts with the oil on your hands and turns it into soap. In the old days, they used to save the ashes from the fireplace, and they would boil the ashes from the fireplace with any grease or fat they would get from animals, like bacon fat or anything like that. You can cook it with the ashes and from the fire and make soap out of it. So that was the way they used to make soap. And I've done it, and it makes you a yellow cake. It looks like the old-fashioned laundry soap. Now with the soap you buy for home use, what they do is they bleach the animal fat to get rid of all the unpleasant odors and all the unpleasant colors, and then they add 2 other ingredients once they finish making the soap. They add a deodorant to give it a good smell, and they might add color to it to give it all the different colors that they have. But if you don't add color to it, it'll just be white, or it might be yellow. But when they bleach it, the yellow goes away. So anyhow, they don't always use animal fats. They can also use vegetable oils like palm oil, olive oil. Any vegetable oil can be used to make soap, provided the base is strong enough, or if you cook it long enough. So some of the pHs of things that we know about. Water, pure water has a pH of 7, which means it has equal concentrations of both H plus and OH minus in it, both of course very low. Blood has a pH of around 8, egg white is around 9, Rolaids around 10, or any antacids that you would take have a pH close to 10. Ammonia is around 11, soap is 12, bleach is 13, and drain cleaner is 14. And you notice they make it a very strong alkali because it helps to dissolve grease and other proteins and other animal substances so that it can clear your drain. Then we should know how to memorize the 6 strong bases. They are sodium, potassium, rubidium, calcium, strontium, and barium hydroxides. They happen to be the group, these 3 are group 1 metals. They're all in line on the periodic table, NaCrB. And these group 2 metals are also all in line on the periodic table, but they're in group 2. So if you look on the periodic table, you'll see NaCrB, Cassarba. That's how you memorize the strong bases. NaCrB, Cassarba. Keep in mind group 1 metals have only 1 hydroxide group with it, whereas the group 2 metals will have 2 because they all have a +2 charge, and hydroxide is only -1. And finally, you should know that acids and bases neutralize each other. If you have a solution of acid and a solution of base, and you mix them together, they're going to form water. The H plus and the OH minus will combine to form water. You could also show it this way, where you show a hydronium ion combining with a hydroxide, and you get 2 water molecules instead of 1. But essentially, it's the same reaction. It's a neutralization of acid with base. If you did this with a strong acid and a strong base, 1, it would be dangerous because they would react vigorously and it might splash. And secondly, it would get quite hot. So that's about all you need to know as grade 9s. And when you come to class next week, we'll play around a little bit with that new knowledge. Okay, so see you then. Don't forget that you have to also study for your periodic table test. If you're in my class, study this week so that next week you'll be ready. Don't show up in class and say, "Oh, sir, we didn't know there was a test," because I've been announcing it now for a while. See you soon. Have a good weekend. Bye.